So anyways, just check your answers to the even problems and let me know which ones you want to work on. Obviously cone, because that's what we're learning. Okay, so prism is to pyramid as cylinder is to cone. Or pyramid is to prism as cone is to cylinder. Parts of a cone are going to look a lot like the parts of a pyramid. A pyramid has a height and it has a slant height. Where's my cone? Here it is. So, a pyramid and a cone, they have a height and they have a slanted height. So we've got the height of the cone, which is perpendicular to the base, and we've got the height of the lateral face, kind of. Ink flavored? Ew. Here's what the net of a cone looks like, if you were wondering. It's kind of this half circle, except not. And then obviously the base is a circle. Here's our formulas. So the formula for the lateral surface area is just pi RL. The formula for the surface area, you take the lateral and you add a circle to it, so pi RL plus pi R squared. And then the volume is just like a pyramid. It takes 3 cones to fill a cylinder. It takes 3 cones to fill a cylinder. Therefore, you take the area of a cylinder and divide by 3. Do you want me to show you why this formula is this formula, or do you care? What's the formula for the LA of a... Okay, thank you. You made me happy. What's the formula for the LA of a cylinder? LA of a cylinder. What is it? Sorry, wait. I don't want the LA of a cylinder. I want the LA of a pyramid. That's a better connection to make. Let's do a pyramid instead. So the LA of a pyramid is, good, 1/2 PL. Now, if we took that formula, and what is the perimeter of a circle? What is the perimeter of a circle? 2 pi r, it's the circumference, yeah. So instead of P, if I put 2 pi r, so instead of P, I'm replacing it with 2 pi r. What happens to the 1/2 and the 2? Cool! They cancel, and what are we left with? Pi RL. So that's where that comes from, if you were wondering. It comes from the LA of a pyramid. All right. Let's try an example. Give you a few minutes to think about this, and then we'll talk about the answers. All right, what is R? It's given to us. What is L? It's not given to us, but with a little bit of Pythagorean theorem, we can find it. What do we get? Good, 17. And the height is also given to us. So now all we have to do is go straight to our formulas. LA, pi RL. It doesn't get much easier than this. 8 times 17. Did y'all get 136 pi? All right. Surface area. What do you add to the LA to get the SA? 136 plus pi r squared. So 64. Ooh, that's pretty. So we did 136 plus pi, I'm leaving it out, r squared. Pi r squared is the base. Cool. And volume. Base times height divided by 3. Base, I'm leaving out the pi on purpose, times height divided by 3. Base times height divided by 3. 8 squared times 15 divided by 3. And don't forget to eat pie for dessert, so tack the pie on at the end. And that would be cubic centimeters. Good? Okay, that one was straightforward. Let's do a composite solid. That's what this is called. A composite solid. It just means it's a solid made up of 2 other solids. Let's always do the easier one first. Let's do the volume first because volume is always easier. You don't like the blue ones? Well, your assessment is going to be full of blue ones. Assessment. The assessment's the day before we get out for Good Friday and Easter. Anyways. Surface area and volume. Do volume first. Because you get a partner for the assessments. Harder than quizzes? Oh, because quizzes are daily grades and assessments are not. So our strategy for volume is simply going to be volume of the cylinder plus volume of the cone. They have the same radius, they just have different heights. You like the daily grades better. Okay, that's probably how it's going to be for the rest of your life. Okay, so volume of the cylinder, base times height. Base times height. Volume of the cone, base times height divided by 3. So are y'all with me on this part? Here, let me put a pie in there just so I'm not leaving anything out. Base times height divided by 3. So type your answer in what you got for the volume. Who's going to type it first? Albert wins! So that was really not so bad. No complaining necessary. 250 pi cubic feet. Not allowed to complain about that. Okay, good. Now let's do the surface area. Remember, surface area is, hey, what is on the surface of this figure? What could I touch if I were touching this figure? So how I like to approach it is in pieces. So what I would do, my strategy, would be to find the area of this circle, area of a circle, plus I would find the LA of the cylinder, because I don't want the top and the bottom. So I'm going to find the LA of the cylinder just around this part. And then I'm going to find the LA of the cone, because we don't want the bottom of the cone. It's not on the surface. You couldn't touch it. So that's how we're going to approach this. Area of the circle, pi r squared. Lateral area of the cylinder, 2 pi r h. Circumference times height. And then lateral area of the cone, pi r, we don't have L, but that's a Pythagorean triple, 5, 12, 13, are we okay with that? 5, 12, 13, it's a triple, memorize it. Ooh, I just barely fit that. Ask me a question about what I've done so far. Are you okay with the strategy? Circle plus LA plus LA. $25 plus 2 times 5 times 6 plus 5 times 13. Are there any steps where you got something different than me? Because please let me know. I got that as well, Albert. Good. Couldn't you just take the total surface area of the cylinder? Sure you could. Yes, that's exactly what we did. That is what we did, Hussein. 150 pi feet squared. Yep, yep, yep. All right. Find the surface area of the figure. This one isn't too bad because we're just finding the LA of a pyramid and the LA of a pyramid. But wait, are they congruent? Are those two pyramids congruent? Yeah. So let's just find the LA of one pyramid and double it. That's not bad. How do you find the LA of a pyramid? One half PL, very good. 1/2 PL. So we don't know L, but we are in luck because this is a 3, 4, 5 triangle. 3, 4, 5. So 1/2 P, which is 16, times L times 2. So the 2 and the 1/2 are going to cancel. Am I going too fast? Oh my goodness, very good job. Yep. 4 looks like it is the whole side. So man, that would have been nice, wouldn't it have been nice? Thank you for saying something this time. Look, you passed the test. All right, so we've got 2 and we've got 3 and we need to find the slant height. Very good. So now we're going to be dealing with a radical. Yep. I think it's, whoa. 2 squared plus 3 squared, guys. There you go, Taha. L, whoa, why are we all getting different things? 2 squared plus 3 squared. There you go, square root of 13. So, let's do this again. 1/2 times 16 times square root of 13 times 2. The 1/2 and the 2 are going to cancel. And what's our answer? (16√13) meters squared. Man, that sure would have been nice if that was a 3, 4, 5 triangle. Wonderful catch. Keep going. Okay, so spheres. Spheres are my very favorite shape. Very favorite. So a sphere is like, you know, a basketball. The earth is almost spherical, except really not quite. A marble, Epcot, a bouncy ball. The balls my girls play in the backyard with, trying to teach them how to catch a ball. You know, they're at that age where you're like, stick your arms out, and you throw the ball, and they just stay right there. They don't do anything. They don't, like, actually try to catch it. It's really cute. Anyways, so by definition, I even think the definition is cool. By definition, a sphere is a set of points in space that are a given distance from a given point. So you take a point in space, a point, like a point, and then you collect all the points that exist a given radius from that from that point. You collect all of them. You go this way and that way and that way and that way. You go in all directions, and it forms a sphere. So I think that's kind of cool. So a good thing to know, another thing I love about spheres, is they're the most efficient shape in the world. Have you ever wondered why when you blow up a balloon, why it starts to form a sphere? Why doesn't it form a pyramid? Why doesn't the air form a prism? Why doesn't it form a cube? Why does it form a sphere? Well, it is because a sphere has the smallest surface area for a given volume. So it's the most bang for the buck. So when you're blowing up a balloon, it doesn't want to pop, but it wants to get as big as it can get. So a sphere has the smallest surface area for the most volume. Smallest surface area for the most volume. So in other words, a lot of things in the real world form spheres. Like when you blow a bubble. I do bubbles outside all the time with my daughters. They love it. I don't know why it's so cool to them. They love to pop them. But when you blow a bubble, it forms a sphere. It doesn't form a cube. Water droplets dropping. Now, gravity makes them look like a teardrop, but we're talking about when gravity is not involved, right? What are some other spheres in the real world, in nature, not man-made? Things that just form a sphere in the real world. Some rocks do. Yeah, water droplets. Here's some more that I found. Ooh, the human eye. That's a good one. I need to add that to my pictures. Atoms. So planets, dandelions, pearls, berries, certain flowers, your eyeball. I'm going to add that one. Are atoms spherical? I'm not your science teacher, so I'm not sure. Oranges, so fruit. I need to put fruit on there too. Good job. Anyways, I just think spheres are so fascinating. The other thing I love about spheres is that they only have one variable. There's no height, there's no slant height, there's no perimeter of the base. Oh my goodness, all there is R. So once you found R, you're done. You just plug it straight into your formulas. And that's why spheres are so awesome. Yes, they do, George. Yes, they do. That's a fun word, ovular, huh? In the movie Star Trek, he says the formula for the volume of a sphere, I believe. I think it's volume. Hemisphere, as you can imagine, is just half of a sphere. So if you're trying to find the area of a hemisphere, you're just going to divide by 2. All right, let's get right into it. There were some of these on your math CBA, right? Why is it 4 pi r squared? Oh no, you want me to derive that formula? I'll have to look into that. So the net of a sphere is kind of tricky. You can't really draw the perfect net of a sphere. So where that comes from, I do know it's the derivative of the volume. So if we could find where the volume comes from, the way you take a derivative is you multiply by the exponent and then you subtract 1 from the exponent. So the 3's cancel and you get 4 pi r squared. But other than telling you that the formula comes from the derivative of the volume, I can't really tell you exactly why. So you can research that. That's your weekend project. All right, so 4 pi 4 squared. 16 times 4, right? Not so bad. 64 pi. Be careful on the volume. Just make sure you're cubing it. You're raising it to the 3. Just be careful about that, okay? So I'm going to type 4/3 times 4 to the 3rd. And it's going to be a decimal. So I'm going to do math, enter, and I'll get a fraction. And Miss Tanton likes improper fractions better. And you know that. Even though you put a mixed fraction. If you have one of these on a quiz, I'm going to expect the improper fraction, not the mixed fraction. Because mixed fractions are almost useless to us. when we're multiplying and adding. Well, I like whole numbers too, but this one's just not a whole number. The volume is 288 pi. Find the surface area. So it's asking us to work backwards from volume. So the first thing that we would do is write the volume formula. And we're going to need to undo everything. First thing that happens is the pi's cancel. So that's super fun. There's two ways to get rid of 4/3. You can divide by 4/3 or you can multiply by 3/4. So it's up to you what you want to do. Divided by 4/3. Are y'all getting 291? Guys, example 2, Earth to 8th graders. What's the opposite of cubing something? Oh. I did 388. Thank you. Good. 216. See why I need you guys? What's the opposite of cubing something? Cube rooting. Do you know where that is on your calculator? Math 4. Math 4. Math 4. Math 4, and then you put 216. Oh, thank goodness, it's a whole number. We don't have to factor it. We don't have to cube it by hand. That's good. So the radius is 6. Now it did say to find the surface area of the sphere. So 4 pi r squared. 6 squared times 4. Final answer. Very good. 144 pi centimeters squared. So do you see what we did? We divided by 4/3 and then we cube rooted. Divide by 4/3, cube root. Would you like to do this problem or no? The numbers are going to be very large. It's not a difficult problem, but the numbers are ugly. Let me see what the next one is, and we can do this one last. Let's do this one, and then whoever's still in the room can do the earth one. All right, so you're going to go buy an ice cream cone, and they're going to scoop it into a perfect sphere, and they're going to slap it onto your cone. Let's pretend, well, it's not ice cream, it's frozen yogurt. Let's pretend before you start eating it, it just starts to melt because it's a really hot day. If all that ice cream melted, would the cone overflow? I think that's fun. It's Dutch chocolate, let's pretend. So what are we going to do here? What's our strategy? Would it overflow? Or would all that ice cream fit into that cone? Yes or no? Is this a volume problem or a surface area problem? It's a volume problem. Yes. So let's find the volume of the cone. Let's find the volume of the hemisphere. And let's find out who wins. The volume of the cone. Base times height divided by 3. Base, there's the base, times the height divided by 3. Now, we're going to want to press the pi button because we're comparing it to the cone, and the cone's not going to be, well, we don't have to press the pi button. We can compare. All right, so 64 pi. And volume of a hemisphere. So volume is 4/3 pi r cubed. But we want to divide it by 2 because we're going to just treat this like a half sphere. We're going to ignore that part right there because it's a hemisphere. Oh no, it's a whole sphere, frozen yogurt, isn't it? The other part's underneath, we can't see it. Okay, sorry. So it's a sphere. All right. So 4/3 times 4 cubed. 85.3 repeating. 256/3. That sounds like the last problem. So it's approximately 85 pi. So is it going to overflow? Yes, it will overflow because the ice cream is more volume than the cone. It's not going to overflow because you're going to eat it. That's cute. Okay, we'll do the earth one on Monday. Y'all have a great weekend. Do the cones worksheet. Do the evens again on the worksheet so that you're not doing the whole thing. Evens will let you know whether you feel good about it or not. Bye.